Hi everybody, this is going to be a quick overview video for Hematocrit. I've been getting a lot of common questions in lab, so I thought it'd be good to put it all in one place. Okay, so let's see. What is Hematocrit? Recall from anatomy that blood is made of solids and liquids. Hematocrit is going to be a measure of how much of that blood is made out of solid materials. Most of those solids are going to be red blood cells, and we get this value by measuring the height of our packed cells after we centrifuge tubes. Let's see. And then, so once you have your value, which you're going to get by looking at that height, you're going to report it as either a percentage, or you're going to report it as a decimal of packed cell volume. And that's actually not the right abbreviation. It's supposed to be packed cell volume. So in this example, let's say it's a pregnant woman who is, we have a hematocrit of 23. So we look at our normal values table, we look at hematocrit, and we see that 33 would be a normal number for her. So she's 10 units under what we would expect, so she might have anemia, and the doctor would have a course of action for that. Let's see. What is the difference between hematocrit and hemoglobin? They are different things. They both measure characteristics of the blood. But hematocrit looks at how much of your blood is made out of cells, and hemoglobin looks at how much hemoglobin is in this blood. Kind of like how much sugar is in this drink or something like that. So as a reminder, hemoglobin can be abbreviated to HB. It's an iron-containing molecule that our red blood cells have to carry oxygen to your tissues. We measure it as a concentration in the blood. Hematocrit can also be described as a concentration of solids in the blood, but it's a little bit more accurate to say what proportion of the blood is made out of solid materials. And both can be used as a diagnostic tool for blood conditions. So usually used in tandem. So let's talk about loading the centrifuge really quickly. Before you load it, you're going to have your tubes. Some tubes are going to have the pre-loaded plugs at the bottom, though they kind of look like cotton. Others are going to come with a tray like this, and you should push it all the way down into there to get a good thick plug. If you don't have a good thick plug, your blood is going to shoot out the other side when you centrifuge it. When you load the centrifuge, you want to put them, your two tubes that you just collected, directly opposite of each other. You don't want to have these guys be your samples that you're spinning, because then this side of the centrifuge is overweighted, and when you turn it on, that's going to make this whole thing wobble and make terrible noises. You also want to make sure that they have the same amount of blood in them. Even if this guy was in this spot, because he has less blood, it's going to be less heavy, and that's probably going to put your centrifuge out of balance. This tube is not pointing the right direction. Always make sure that your tube is facing outside. If your tube is on the inside, there's nothing to stop the blood from just shooting out that tube. And then you'll get a bunch of splatter paint art on the inside of your machine. So always have that plug on the outside. And then just one more thing, when you're loading the tube, make sure it is pushed all the way to the edge, like these guys. You don't want to have that gap between the clay end and the edge of your centrifuge. So let's talk about preparing the hematocrit tube for a second. You need to fill the tube at least halfway, and at most 3/4. If you don't fill it at least halfway, you're not going to have a good enough amount of blood to get a very accurate reading. Also, the chart, it just isn't going to work for you. You put it in the centrifuge, and then you get this sectioned tube right here. And this yellow area, this is your plasma. Plasma is the liquid portion of your blood. Plasma is composed of serum and dissolved substances. You can describe serum like the broth in your soup, and dissolved substances are going to be like the noodles and stuff. And dissolved substances are going to be like lipids, carbohydrates, proteins, and one other thing that I can't remember, but salts. I don't know if I already said that. And then you're going to take this tube and you're going to read it on the chart, and you're going to be reading the height of your solids. Solids include the Buffy Coat and the red blood cells. So this little guy right here, that's your Buffy Coat. And your Buffy Coat consists of white blood cells and platelets. Sometimes you don't have this, sometimes you do. It's just make sure you measure from the top of it. And then this is going to be your just like huge packed column of blood cells. Okay. Reading your tube. I recommend doing what this person is doing in this photo, which is holding the very ends of the tubes by their fingertips only, so that they can keep the rest of the tube open and readily visible, so it's easier to line it up with a chart. This person's also holding the tube vertically, so like straight, I don't know, that's not a very straight line, but straight up and down, so that's parallel with the edge of the chart. You do not, let's see if we're over here, or for example, if we were here, we want our tube to be like that. If it's a little bit like that, that's going to really alter your values, and if you're really like that, you are not going to be anywhere near the number that you need. Alright, so we're holding it down by the tips, we have it aligned up and down. The next thing we look for is alignment on the bottom. So we have this plug here. You want the top of the plug to be at the same level as the 0%. And that's because you really just want to be measuring the height of your solids, and if you include the plug, you're essentially adding false value to how much solids you have, so you'll get a falsely high value. And I'll describe that a little bit more in a second. So once you have that rod tube aligned with the clay plug right up against that 0 line, and this tube is like vertical, you can start kind of towards the ends and start moving it around until the top of that serum is lined up with the top of the chart. So we want that very top of your sample to be right there. So the end result is the only thing that is on these lines is yellow and red. We don't want any of the empty space in the chart, and we don't want the clay plug in the chart. So once I have everything aligned, if I have that aligned, and it's vertical, you take a look at this interface between the liquid plasma and the solid red blood cells, and you look at, okay, what line is this on? I'm going to say it's on that one. Gotta clear this up a little bit. Then I'm going to follow this line all the way to the edge here. I've had some people having difficulty understanding how to read this thing, so I'm just going to go over it really quick. So we pay attention to these dark lines because they're going to be our 10s. So we have a 30 and we have a 40. There's 10 units between those numbers. If we look at our lines, starting at 30, we have 1, 2, 3, 4, 5. So that is 10 divided by 5. So each of these little increments are 2. So if my line is here, I'm going to count 30, 32, 34, 36, and then 38, and 40. And because, oopsie, our line is right here, that's going to be 36. So that's my first value. So you'll remember that we have 2 tubes. You will record that first value for your first tube, And then let's say maybe my second tube read as 38. That's my second value. You're going to want to take the average of these two values. You do that by adding them up. So 36 plus 38 is, let's see, 6 plus 8 is 14. And then you divide this number by 2. So 74 divided by 2 equals, oh, math. 37. Yes, 37. So 37 is going to be your value that you report. You would write 37% or 0.37% in the chart. Okay, so I'm going to go back and just review a couple of things really quick. All right, hematocrit is a measure of how many solids are in your blood, and it's expressed as a percentage. You can also express it as a decimal with PCV after it. Hematocrit and hemoglobin both measure characteristics of blood, but they're looking at different things. Hemoglobin measures the concentration of the iron-containing molecule in the RBCs, and hematocrit is looking at the solids. So that will be the actual red blood cells. And both are used to do hematology studies, so they're often done in tandem. When you load the centrifuge, make sure the clay plugs are on the outside and pushed all the way to the end of the slot, and they are directly opposite of each other. And give yourself a good clay plug. You don't want your blood falling out. When you have, once you've spun it down, the liquids are plasma, which is made of serum and dissolved substances. The solids, which are the part of the tube that we're going to be measuring the height, contains the Buffy Coat and the red blood cells, and the Buffy Coat will contain red blood cells and white blood cells and platelets. And then when you go to measure your tube, you measure both tubes, you take the average. You want to make sure that the bottom of your clay plug is aligned with the top of your clay plug is aligned with the bottom of your chart, and then the top of your serum is aligned with the top of your chart, and you want this tube to be vertical. And then you go and look at the line that matches up with the intersection, and then you read that value. Oh, heck. Okay, I think that's it. If you would like additional help on any of this, just let me know. I would be more than happy to help you. Yeah. Okay, cool. All right, everybody. Well, happy studying, and I will see you in class.